installment of our trig problems. Next one, we're looking for all of the angles which have this property where secant theta is equal to 2 over radical 3. I personally am not a huge fan of secant, cosecant, and cotangent, so I'm going to immediately write this as its reciprocal, which is the reciprocal of secant is cosine. So I know that I'm looking for where the cosine of theta is equal to radical 3 over 2. Okay. Now I'm going to go back to my step 3, step 2, step 1. All students take cash. Where is secant and cosine positive? Well, everything is positive in quadrant 1. Also, cosine is positive in quadrant 4. Moving on. Special triangles. You have to look for key information in our trig ratios to decide if you're working with a 45-45-90 or with a 30-60-90. Here we have the radical 3, which is telling us that we're working with a 30-60-90. Okay. So again, if you have trouble remembering where the ratios go, think about the size of the angle corresponds directly to the side length. So the smallest angle, 30 degrees, is across from the smallest side ratio, 1. The hypotenuse is always the longest segment of a triangle, so our longest side length ratio, and the last space available gets radical 3. Now we want to think about which one is going to give us a cosine of radical 3 over 2 or a secant of 2 over radical 3. This is a hypotenuse over adjacent. So we're looking for where radical 3 is the adjacent angle. Here radical 3 is opposite from 60 degrees, so it's not 60. And it is adjacent to 30. So we're looking for 30-degree reference angle in quadrant 1 and 30-degree reference angle in quadrant 4. Again, our reference angle is the angle formed between the x-axis and the terminal side. So again, in quadrant 1, our reference angle is the angle in question because everything from 0 to 90 is itself. And then in quadrant 4, 30 degrees reference angle is almost a complete rotation minus 30 degrees. It's a full rotation less 30 degrees. So I'm going to do